Hey guys, and welcome back to the Amateur Aerodynamicist. I'm back talking about the team that has had the most flailing start to 2025 among the top. That's obviously Ferrari. A team that had huge expectations coming into this year with their lineup has underperformed massively, egregiously, if I am to use the entire English vocabulary to say it well. Now, it started with a pretty dismal P8, P10 and Australia, followed by hopes at the China sprint, which immediately broke over by a double disqualification for Ferrari, and followed by even worse races, with one podium in Jeddah thanks to Norris being out of position, and one meager sprint podium once again in Miami from Lewis Hamilton due to a rain affected race and changing conditions. But where did the technical development go wrong? This is the same team that was fighting for the Constructors' Championship until the last race of last season and was having a podium at the opening races. So, what exactly went wrong? It's a two-part analysis. We'll first have to look at something you might not want to think of. And first of all, you'll think, what is the major thing they changed? Because they said we're changing 99% of the car. What is the major thing they changed this year? It is the front suspension, which has been changed to a pull rod, but it is not that. How do we know it is not that? Let's look at the other car running the Ferrari parts. This is helpful about Ferrari because a lot of cars run our parts, so we know exactly what they're running. The other team that we usually used to look to was Haas. Now, Haas is not running our pull rod front suspension, but Haas is running the rear suspension arm of ours. This will come in handy later. They are facing the same problems as us, and clearly, since they don't have the pull rod front suspension, it means that the problem lies with the rear suspension geometry. And this is where we come in to the rear suspension pretty clearly. This you can see the rear suspension. Now, the rear suspension is connected to a very interesting bit called the gear casing. Now, the gear casing is essentially where the gear is kept. Essentially like this thing is kept in the gear. Now, how does this connect to the suspension? You'll see here. Look at this. Can you see this casing right here? That is your gear casing. Now, what could be the thing when you change the gear casing around a lot that causes your suspension to go wrong? Well, let's look at the first problem they faced in China, because we can't take Australia, that's a wet race, so we can't take technical fundamentals there. At least I can't. I'm not that good that I can take wet races as a technical fundamental. There are others who can do that, but I'll take the China disqualification for case. So if we look very closely there, Lewis Hamilton was disqualified for plank wear and Charles Leclerc was disqualified for too little weight under the 799 kg. So of course, we don't know what was like less plank, like probably it could have been worn as well. But looking at Lewis Hamilton's plank, it was worn. And when does a plank wear? Because when it's hitting the car, hitting the ground a lot. And that just doesn't happen simply to rear ride height. It's also because if you have a compliant rear ride height, your rear suspension might be flexing so much to the point that it's constantly hitting the car constantly again and again and again and again. That will cause wear to your plank because your plank is ultimately located in the floor, which is again and again hitting the ground. That is the entire point of plank wear. That is how it happens. This could exacerbate that. Now look at it. A gear casing is essentially where you are connecting the suspension arms in this case. If a gear casing is too soft, if a gear casing is not as rigid or as controlling as you'd like it to be, it's like the um, the middle part of a tree which roots you in the ground. If that's not strong, if the branches are moving from left to right, it will squat a lot, and that will lead to issues exacerbating the front lower ride height going up and down, up and down. That will exacerbate your entire plank wear once again. So looking into that again, if there is a very soft casing in this case, and that is what I'm referring to in this case, would refer to this part. As you can see, this is the part where I'm referring to. If it's too soft, it will cause a problem of wear. That is because it will cause too much of suspension travel. So the suspension could travel from here to here, from to here to here. Probably I'm drawing it wrong. It is traveling till here and here. So eventually your floor is going all the way down. That is a major problem. That is the first part of our problem. The second part of our problem, I'm going to be explaining it as well. It is consequential to this. So that's how the first problem can be solved for Ferrari, and that's how we've diagnosed it. Let's have a look at the second one now. So let's just begin once again from where we started, where we left off. What we were talking about is how the rear suspension traveling more than it usually does due to the softer gear casing will cause a problem. Now, yes, it will cause a problem, and I want to demonstrate that to you with an example. Now, I'll show you a car under load, how it performs, how the floor moves, and then we look at how the Ferrari's floor would move, because I don't have accurate pictures of that. It's tough to get pictures. I'll explain to you how it works. So here, first of all, we have the picture of a car. That's an Alpine A524. That's a 2024 car of theirs. In turn for entry at the Emilia Romagna Grand Prix, it's in a medium downforce setup. It's a soft tire fuel load with 10 kilos of fuel in it. It's a Q2 run, fast, cool, fast. So it's not on a race run, which will come in handy later. First of all, let's observe how the car is right now. You may not observe it at first, but let's have a closer look at the white line. So I'll zoom in so everyone can see. Notice how the car is slightly deviating towards a certain angle. That's yaw. Now, if you don't know, yaw is essentially when I'm going somewhere, when I'm turning, my body tilts slightly towards one side. In the simplest way I can explain, that is yaw. When you have an airplane making a heading change, it turns. Okay, there is a sense of yaw in that case. Just search up yaw. It's an aerodynamic term. I can't explain it any simply, but this is what is happening. Under the movement of yaw, the movement is yaw, not the effect. Now, in the effect, there's a deviation. It's because the load shifts. Now, when we're going straight, okay, so assume this, right? We're going straight, the flow is like this. When you're turning, so in this case, we're turning left, right, the flow shifts to the right. That is where the flow is shifting, and that is why notice this part is lower than the other part. It's because the load is shifted there, so it's like a seesaw, right? So if there is more load on the left, obviously the seesaw will go down on the left and the right side will come up. It's also how a weighing machine works, a manual weighing machine, not the fancy digital ones nowadays. So observe this, and now looking at it again, you can just take a look at this very clearly. You can like understand it even. Look at the difference. Look at the difference of the deviation. The deviation is much lesser in this case. It's pretty much nothing at this point. It's nothing. It's like I've aligned the line, and in this case, there's a massive deviation. Is this here. Now you can see this in F1 terms. That's a massive deviation. Now, how is that causing an effect to the floor? I'll explain it to you once again very simply as I have done. Now, this is the turn in direction floor edge. That is on this side. How is it appearing? How is it appearing on this side of the floor? This is how it's appearing. It's pretty normal. Looks to me like there's a little bit of distance here between the floor and the ground. But now let's look to how is it appearing in the other side, that is the side under which there is a lot of load. So if we move a little bit towards that side, which we'll do right away, you'll notice that the floor, especially towards the rear corner, is getting very compressed. You can just notice that it is pretty much touching the thing. It is pretty much touching the ground, whereas it was not in this case. Obviously, the front is not touching that much, but it is much closer. It is razor thin margins versus, look at here, there's this. I mean, it's pretty obvious. You can just see it. One line fits here. Okay, let's go back to this part again. One line doesn't even fit here. It's half that. That's because under your entire car literally tilts. I'll explain that with the shape now, making it a bit easier for everyone to understand. Okay, so yeah, not everyone's a crazy person like you can visualize it. You don't need to be that crazy either. So let's explain that very simply put for you. Okay, so looking at it here, we can see that essentially this is your car under a straight line. When your car moves to a certain side, let's assume in this case again it's moving left, your car tilts slightly downward because the load will shift. Now this is a very aggravated turn. Okay, now it won't shift this much. If it shifts this much, your car floor will literally scrape. You don't want that to happen. It shifts, but it does shift, and what that causes is essentially aerodynamic sealing, which means the air that is flowing through one side of the car actually goes to the diffuser because there's nowhere else to go. But because Ferrari has to run the car higher, there is littler aerodynamic sealing. You can't seal the air as much. Now, talking about aerodynamic sealing, I'll help you understand it a little bit better. So let's just build a neat little diagram right here. So assume this is your, You know what? Let's just draw a cross section of a floor. Now, obviously, you don't expect this to look like an actual floor because I'm just drawing it. You've got the tunnel, the boat. So very simplified version of floor. This is your vortex generators on both sides. This is your diffuser. This is your rear wing. This is your front. This is your rear. Now assume you're turning in. We're not taking any direction because I just don't want to mess up by saying left and right and left and right. Let's assume the wind is. Let's assume you're turning in windward. That is towards the wind. It's coming from here. The air will flow in whichever way you're essentially going to turn. You can't have opposite airflow coming in. Yes, you can. It's a crosswind that causes more variables, but assuming this fairly simple thing in this case, I don't want to make it too confusing. So let's simplify it, not cause any much problem in this case. So yeah, as your air flows inward. Oh, I just realized I could have used a better ink. That is that sorry. So that is clearer for you guys. I'm sorry, it just slips out. Let's just put. Okay, it's green. Fine, whatever it is. Assume your flow is coming in from this direction in this case. When there is no aerodynamic ceiling on this end, that is, your floor has not reached this state. Okay, it's not reached this state. It is at this state. So when it is at this state during your turn in, it means it's at a higher state when you're not in turn in, right? Because you're running with a higher ride height. Now, can you remember the fact that Ferrari has been saying we can't race with a low ride height anymore. We have to raise it. And now you'll understand why is that causing them a problem. And why exactly do we always say that it is causing them a problem when you can't put it that low? It's because in these ground effect cars, you need them to run low in order to actually make a difference. It's the entire ground effect era. It's the closer you can get the floors to the ground, the better they perform because they create that pressurization. They create the venturi tunnel. They create that suction to the ground. That's what keeps them. That's the downforce in it. Now, when there is no aero ceiling in this region, the air, some of it goes here, okay, some of it goes, but the rest of it just escapes out. It's as simple as that. It's not really complicated. It's just how much air can you actually direct towards the flow for useful purposes and how much you are not able to do it. Now, when there is ceiling, however, that will be red when there is ceiling. Let's have a look at how is it when there's ceiling. When there is ceiling, however, you have very little air going out. Yes, there are some niches where you can use air, but in the ideal case, you will not be losing much air at all. You will lose probably maybe a little flow of air from here, or mostly you'll be losing from here because this part is pretty much entirely sealed. If it seals a little bit more, it's touching the ground. That's a problem, but you don't want that ideally. So it's sealed pretty much, and most of the air is going through here. It's going to generate your downforce in some or the other way. That is the main reason why Ferrari is failing to generate the downforce it does. It's a very aerodynamically efficient car. The problem is not with the car, with the on-body aero, it's with the lower part of the car. And because this particular suspension has a travel issue because of the soft gearbox casing, it means first of all, you can't replace the gearbox casing very easily because an entire assembly line has been dedicated to it. Changing it is not very easy at all. So you'll have to go with something with regards to the suspension mechanics, which is what Ferrari is aiming right now. Obviously, there are reasons other than this why it's slow. There are brake ducts, like I had explained in the McLaren video, but I'm explaining the suspension only one in this case. That is, of course, an entire video in itself, the brake ducts. So, what they're going with is the suspension upgrade, changing the mechanics of the suspension because of the softer gearbox casing. The suspension travel is much more exacerbated. You can't control it as much. Hence, they're going with the changes as we'll see. Obviously, I don't know what changes they're going to come with, but the essential thing will be so that you can reduce the amount of travel in the suspension that will allow them to run the car lower and not at risk of a DSQ. Currently, they can run the car lower. It's not a structural problem. It's just that they'll probably get DSQ'd or have a higher chance because the car is just flexing beyond what their simulations can predict in real life, right? So that's the entire problem. I hope you guys liked it. This is my understanding of what is the problem with Ferrari. Thank you guys for watching. If you have any suggestions, let me